Let's draw the user interface for our block entity. Hello, everyone. This is Ali Reza. Welcome to the Mentor Code Lab. In previous episode, we created the screen handler and the screen renderer classes. And at the end of the video, I told you that in this video, we should be able to draw the GUI and right-clicking on the block and the GUI will come up. However, after recording the video, I noticed that my code had a little bit of a problem. And I will fix that problem and tell you why. And then we will move forward in this video. And at the end of the video, when we right-click on the block, the GUI will show up. Now take note that in the previous video, we extended our block from synced BE from my library, but then we implemented the extended screen handler factory. Now, if we recall on the G block, when we want to open the menu, so if I go onto the unused, we are checking if we are IBE screen. Because I'm directly calling extended screen handler factory, no matter how good my GUI will be, no matter how much I try to draw the GUI, nothing will happen because this check will fail and the open handle the screen will not be called. To fix that one, we can say that we are IB screen of that payload, or alternatively, if I want to, I can call the screen synced BE and remove this implementation. However, screen synced BE needs two generics. As you see, it asks for a T and a B. The T is the type of the block entity. However, the B here is the payload, okay? And everything will work because, well, guess what? The screen synced BE is already implementing IBE screen, and this is how you know that the B generic is actually the payload because we are using it in here. So far, so good. So we fixed one problem related to our block entity itself. Now, by default, everything should work. However, we have another problem, but I prefer to show that in the game. So let's run the game and see what we have right now. Okay, let's go into the world and take a look. Right now, I will try to right click on the block, and you may notice that we have something that is popping up and going down. I'm not drawing anything right now, but we have this overlay popping up and then vanishing. In other words, for a single tick, we will see the GUI, and then Minecraft makes the decision that the GUI will not show up and should not show up, and it removes it. If you ever see something like this, there is another problem related to your screen handler. Because we just added the screen handler and we said that, hey, implement the methods and then we'll leave it alone, we have this can use that returns false. That is the problem right there. It says that, you know what, we can't use this screen. So we are trying to show it, it will pop up. The next tick, Minecraft asks the system that, hey, you know what, can you use this? And the system says no, because we are returning false. And Minecraft will remove that graphical user interface. So if I return true right now and I relaunch the game, but I will relaunch it in debug mode now, you will see that the graphic user interface will come up. Of course, we are not drawing anything in our renderer right now. Okay, let's go into the game. And now if I right click the block, we will see that something nice is happening. And there we go. You see that REI is showing up and it's staying there. It means that we already opened the graphical user interface of this block. However, of course, we are not drawing anything. And because of that, it's just blank in the center. So why did I use the debug mode? When you are rendering the screen and you are handling this screen renderer, normally you will add things inside the init. There are background and there are foreground and render. Because of that, you don't need to constantly rerun the game. You just need to use the hot swap and your interface will show up with the adjustments. Anything that is client side, rendering, music, I don't know, maybe the renderers for the block entities, things like that can utilize this power from the debug mode. However, I think we will need to rerun the debug mode at least once and you will see why. So we want to draw the background, and the background is a texture file. But the way Minecraft addresses these texture files are by using the identifiers. Identifiers are the address of the texture on the system that tells the Minecraft, hey, this is the texture I want to use. So the very first thing is that we want to have a private static final identifier, and we can call it whatever we want, but normally people call it texture. Now, keep in mind, if you are dissecting the interface into multiple texture files, you want to name them carefully here. But because we have the background all in one texture file right now, we can use the texture name here. And we will call the reference, and please add the static import dot identifier. Now the path will start with the textures forward slash GUI forward slash container forward slash gem cleaner.png. Few things that you need to keep in mind. First, make sure you don't have any typos. You start with the textures folder, not the mod ID or anything else. Textures, GUI, container, and this is the file name. And the last thing, the extension of the image should be included into the identifier. So we have the texture. Now we want to draw it. To draw the texture, we can come back all the way to draw background and say screen utils from my utilities dot draw texture for the context with the texture file with this.x, comma, this.y, comma, 0 as the u and 0 as the v, this dot background width and this dot background height. Now, let's take a look at this utility because it's my library. You want to learn the vanilla way, and this is where the vanilla thing is happening. I'm already calling another overload. However, in this overload, we are using the context, and this is the vanilla way of doing it. You need to draw the texture on the context. You will use render layer, colon, get GUI textured, then you will assign the texture X, Y, U, V, width, and height, and then these two, texture width, texture height, and one final variable, and that is the color. Now, you notice that here I'm using -1 as the default color when I call this overload. -1 means that, hey, don't change the color of the overlay. If you want to add a tint of, for example, red on top of your GUI design, means that you have this GUI design, but you want to tint it red on top of this design, you will send a different color using this overload. And as you see, I have other different overloads that you can use here, but the basic call is this guy. Now let's talk about what we have here. Context is actually the draw context in Minecraft. Now, in recent versions, if I call it, it was 1.20 that something, Minecraft moved every call to draw something into the context. So you see that here we have a draw call, we have draw border, draw center text with shadow, draw GUI texture, draw horizontal line, draw hovered effect, draw an item, draw even item tooltips without entity, order tooltip, sprite, stack overflow, draw text, draw texture, and the things goes on and on and on. Okay, we can even fill some borders, we can fill with gradient, and these are normally the contents that you will use. And thankfully, Minecraft will handle the OpenGL calls for you. Way back in the history, we had to work with the OpenGL calls ourselves. For example, I'm not sure if we can see this in here. Let me see. Not yet, not yet. Here we go. You see that it is using vertex consumers, it is adding vertices, and then it is adding the layer, get position matrix, and stuff like that. However, still, you won't see anything directly related to OpenGL. Now, if you dive into this, you will find something that is related to OpenGL at some point. And you know, Minecraft wrapped itself around OpenGL so well that you don't need to directly call OpenGL anymore just to draw the textures for the GUI. However, in future, you will see that we have to somehow come up with alternative usage of context for drawing and rendering stuff in 3D then. But the thing is that I think it was 1.7.10 that I used way back in the history. At that time, you had to directly call GL commands, set the texture color, then set the texture, then draw the texture, and work with matrices. That was a pain. Okay, and Minecraft removed that pain. As you see, the only reason that we have a utility is just to get ourselves free of just calling this render layer GUI, because people may forget this one, and we remove the need for the color. Other than that, these days you just draw a texture for the user interface with one single line of code. Now let's dissect into these parameters and understand what is going on. Well, the texture is the texture file. That's obvious. Then we want to draw it on the x coordinate and y coordinate of the screen, and we start from 0 and 0 on the texture file. So the x and y has nothing to do with the texture size or the texture file. This dot x and this dot y is the coordinates of the texture on the monitor when you want to draw it on the game. However, u and v, u is the coordinate of the texture horizontally. So in this direction, you are working with u. On the other side, the vertical side, you are working with v. Now the thing is that the top left corner is the 0 and 0 for the u and v. Okay, so this is our coordinates origin. As much as we go toward right, we are increasing the u. As much as we go down, we are increasing the v. Okay, knowing that, now we understand that we are starting from top left of the texture file. Now, how much should we draw? I mean, should we stop here or should we draw the whole texture? This is the width and height of the drawing. Okay, so we say that, you know what, we want to go this much forward and then this much down. However, we have two more parameters. These two parameters tell the system how deep our texture is, what is the size of our texture. Okay, so let's take a look at that. In the init phase, you can put it on the constructor. Some people put it on the constructor. Some people put it on the init. I prefer to use constructors because this is where the things start. So we say this dot background width equals to some number, and this dot background height equals to some number. Let's go into Photoshop and figure these things out. Okay, take note that this is the PNG file, not the Photoshop file. I will go with this select tool and I will just hit Ctrl A. This will select the whole image, okay? And I will open this info panel. You see that the width is 256, the height is 256. Okay, we need that information here. So the width is 256, the height is 256. If I want to draw it as I coded, guess what? We are starting at the left corner. We tell the system that the image is 256 by 256, but these two parameters tells the system that from the left hand side, go 256 in the width and 256 on the height. So I will draw the whole thing. That is not what I want. What I want is to draw this section from here all the way to here without even 1 pixel as an extra. So the width is 176 and the height is 189. Okay, I have two different ways of doing it now. The width here will be changed to 176 and the height will be changed to 189. Now, trust me when I say this. When you are working with graphical images and things like what we are doing here, it's not a bad thing to have some constant numbers on top. So we have private static final int, and we call it texture width equals to 256. Okay, the other one is texture height, then the other one is background width, the other one is background height. Background width will be 176 and background height will be 189. And here we can utilize those numbers. So this is texture width, this is texture height. Here we will use the background width and background height. Now you notice that we have this problem. This is the background width, by the way. So the error is gone now. Finally, we are ready to watch it in the game. Now, take note, because I added some fields on top, if I use hot swap and come back into the game, let the hot swap finish, it says operation not supported by virtual machine. I don't know. Let's do this. If I try to open, nothing will happen. So I have to rerun the debug mode again. But from this time forward, because we have our variables and everything we need, if we want to draw anything else, well, we are just lucky because we don't need to run the game again and again and again. Let the game come up and we will see what we have. Okay, we have have few different problems now. We can see the GUI in the interface. However, one, the inventory text is in a very bad position. The gem cleaner starts from top left. That's the default behavior. We want it to be centered. And the most obvious one, our user interface is not centered on the monitor. So let's fix them. I will move it to the second monitor. The very first problem, the inventory name. Let's go inside the init. We say this dot player inventory title y equals to, I don't know, 10,000, for example. By doing this, we effectively said that, you know what, I want this inventory to be drawn outside of the borders of my monitor. So we will never ever see it. Of course, you could play with these values and make the inventory show up somewhere around here. But again, I don't want that, Then I can take these and put them inside init. As I said, it's totally possible. And instead of texture width, I will go with background width and background height. Then I want to get rid of these two parameters, this.background height, this.background width. The reason is that in our utility, we have an overload that doesn't need the texture width and texture height, and the texture width and texture height will be set to 256 by default. So if you are using a standard texture size for your graphical user interfaces, normally Minecraft uses 256, so you don't need to send those two parameters over and over. Finally, for the text width, we want to make sure that our text is being drawn at the center of the user interface. For this, we say this dot title x equals to, let's see, it says this dot width minus this dot background width. No, that's wrong. You say this dot background width minus this dot, yeah, that one, text renderer dot get width for the title. Now, this part returns the width of the title, and we reduce it from the width of the user interface. So this is the width. We reduce the amount of the text width, and then we divide it by 2. Effectively, by doing it, we will center our text on the file. Let me pin this bad boy to the monitor so that when I click here on the hot swap, it will not jump down, and see what we have right now. So compiled, you don't see anything change, but if I just get out and open it and now go into full screen, you see that 1, the interface is centered. 2, we don't have that text for the inventory. 3, the gem cleaner is now centered properly. All I had to do was going out of the user interface and move back in, and the interface is showing properly. Now, from here on, we can progress forward. One of the things that we want to draw is this fluid gadget. Now, the fluid gadget is something that you may want to draw on top of the fluid. For example, let's say that we have some water being filled in here, and then on top of this, you want to draw those gadgets. So you will have a red line on top of the water, and you will have something like here and here. For example, the thing that we are really using, it is having more markers, but you get the gist. Now, if I call this draw call on the draw background, when I'm drawing the water, those markers will be below the water level. So you will not see some of it. To draw them in front of the water, you need to draw them as foreground. Now, remember, we have background, we have foreground, we have render, and each one of them has their own usage. For example, draw background will be called, I think, once, and when you draw it, the system will not call it in every single tick. I think that's the case. So it's optimized to draw a background. However, the render is being called every tick, and I think draw foreground is called every tick. I'm not sure about the last one, the draw foreground. However, we want to draw something on the foreground. Let's figure this out. First of all, yes, we want to draw the texture, but where is the position that we want to put it? If you recall, I have Photoshop file. Let me open that Photoshop file. The reason I kept this Photoshop file, as I remembered and as I told you, is that we have this temp group. By turning on that temp group, I can come back here and, zoom in. And of course, I moved things around, so I need to adjust it right now. But using that energy gadget, I can do that. And now we can see what we are doing. The top line here will be drawn here. So this single pixel that my magnet is in it is the coordinate that we want. I will go to the move tool and move my mouse here, and inside the info window, I'm taking a look at this X and Y, and I see that it's 83 and 34. I need to remember that. So it's 83 on the X. So instead of this dot X, I need 83. And the Y is 34. This is where we start the drawing. However, we have 4 more parameters. The U means that where should I look for the texture that I draw? And guess what? This is the texture that we want to draw, these red lines. And the start is here. So the U is 184 and the V is 0. Again, 184 and 0. Finally, we have the width and height. Let me zoom back a little so that I can see the whole thing. I will go to the select tool and I will select this section in the texture. The width is 16, the height is 51. So guess what? 16 and 51. And if I do the hot swap now, you see that it's been drawn there. Take note, this time I didn't need to go out of the block and reopen the GUI because as I said, now it's confirmed the draw foreground will be called every tick. And because of that, it's drawing the thing again by itself. Now we have 2 more things to draw. However, here's the question. What is the use case for the render? Now, render is being used for draw the tooltips, okay? If you want to draw a tooltip, for example, on the energy bar or the fluid container, well, that is the thing that we want. However, right now, I just need to draw the progress and the energy bar. So I will copy this 2 more times. And don't forget, it's a good habit of putting comments so that you know what you are drawing at each line. Here we are drawing fluid markers. Here we want to draw the progress arrow, and here we want to draw the energy bar. Of course, we don't have any progress, we don't have any fluid, we don't have energy. That's irrelevant. Right now, we just want to draw them, okay? So now for the progress, we need to find the X. The X is here. So my mouse is here, 133 for B6. So 133 and 46. The U will be the start of the arrow. And the start of the arrow is exactly here, right here. So it's 176. Now the V is actually 0. And finally, we need to get the width and height. So I have to select from there, go all the way. And remember, it's a little bit hard to see, but if you have a red background to help you, you can turn it on and see the arrow properly. Or actually, I can even, do this and have a better coloring. So I need to start here. I need to go all the way to here. The width is 8 and height is 26. So the width is 8 and height is 26. Okay, let's use the hot swap again. And here is the arrow. Now you notice that it's offset. This is when you notice that you did something wrong. The thing that I did wrong is that I took this single block's address. That's wrong. The X should start from this one, and the X for this is 131. So I did an offset for the drawing and it's not fitting properly on the monitor. Again, do a hot swap and it's now fit. Now here is the thing. If I reduce the height to be around, for example, 20, what will happen? This will happen. If I say it's 16 and run, this will happen. In other words, as I am using the progress on the crafting, I can draw an arrow from top to bottom until I hit 26 pixels. That is a full arrow, and that is when our progress is finished. Okay, now for the energy bar, we start from this corner. It's 154, and then the height is 29. We need the U, that is 200. Of course, the V is 0, and then the width and height 14 and 16. And let's do the hot swap now. So we have our energy bar. Now, guess what? If I move my Y downward, for example, let's add 30 pixels, and then I will remove height with 30 pixels. Actually, I did add 10, I think. Yeah, let's add 10 and it will be 39. Let's reduce 10, it will be 52. And let's do the hot swap. You see that I'm dropping the energy from the top. So I will add, I don't know, another 10 and reduce another 10 from here. Do the hot swap and it drops down. This is how you will draw the energy. Actually, you will go from bottom to top, okay? So right now I'm using the full width and full height just so that when we open the user interface, we see everything. And right now, we have everything that we want to draw except one thing, and that is drawing the water fluid inside the fluid container. Now, in this case, it's actually easy because you know what? We are dealing with water and water alone. Before I'm drawing the gadget, okay, before I'm drawing the markers, I will start drawing the water because I want to put the marker on top of the water, okay? So we say fluid, we call it fluid, equals to fluids dot water. And now that we have the fluid, we can say that long amount equals to, I don't know, fluid constant dot bucket. Don't worry if you don't understand what I'm doing right now. We will talk about fluids in depth, but basically I'm putting the boilerplate code that I will need in future to animate this fluid inside the height. So we will say that the capacity is actually equals to 10 buckets. So right now I am hard coding that I have 2 buckets of water and I have the capacity of total 10 buckets. Then we can say int fluid height equals to math.round the fluid amount, the amount actually, divided by capacity, okay? However, we have things to cover here. First, we need to typecast this amount to be a float so that the rounding will work properly. And then the result will be multiplied by the height. Now, here's the thing. What is the height of the fluid? Let's go back here. Let's go down. This is the internal space of the tank and the height is 62. Okay, so I will define another integer on top, int bar height equals to 62, and then we multiply it by bar height. Then we start doing our shenanigans. So far we just found the capacity, the amount we have, and the height that we want to draw the fluid. Okay, so this fluid height will be 0.2 by now because we are 1/5 of the full capacity. Now here's the question: how can we draw the water inside the container? To draw the water, and this will happen in the next video. If you like these videos, please subscribe to the channel, hit the like button and turn on that bell so that when I publish a new video, you will get informed. Have fun everyone. Bye.